Hello everyone, I welcome you all in the C Programming and Data Structures lecture. This is part 2 of Reverse a Stack using two stacks. In this presentation, we will continue our discussion on how to reverse a stack with the help of two temporary stacks. So without any further delay, let's get started. How to write a C code to create more than one stack? In the previous presentation, we have seen how to write a code for the implementation of the original stack. But we are also interested in implementing the temporary stacks, right? Is it okay to have global declarations of top 1 and top 2 pointers? Is it okay to have the global declarations of these 3 pointers? Or we might face some problem. We'll see the answer to these questions in this presentation. Let's continue with our discussion. We have to implement multiple stacks. For this purpose, of course, we have to declare struct node. And here we must declare all these pointers, right? These are the global declaration of these pointers. You can see top pointer is declared, top 1 pointer is declared, and top 2 pointer is also declared. Here you can see that null is initialized to all these pointers. But there is one small problem. Actually, push, pop, is empty, and print functions work only with top pointer. We already know this, that push function, pop function, is empty function, and print function will always receive this top pointer and will never receive top 1 and top 2 pointers. Why is that so? The actual problem is, first we have to pop an element from the original stack and then we have to push that element in temporary stack 1. This is the original problem. Actually, we have to pop an element from the original stack and we have to push that element onto temporary stack 1. Now you might think, what is the problem behind this? Actually, we have to perform the push operation on temporary stack 1, but we know that push function will always receive the top pointer and not the top 1 pointer. This is the main problem, right? Here we have these 3 stacks. We want these 3 stacks for the purpose of reversing all the elements of this original stack. Currently, push function, pop function, is empty function, and print function is capable enough to work with original stack only, but they are not capable enough to work with temporary stack 1 and temporary stack 2. This means that we can perform all the operations on the original stack, but we cannot perform the operations on temporary stack 1 and temporary stack 2. Here, we are interested in pushing this element onto stack, that is temporary stack 1. But how to do this? And this simply means that push function must be capable enough to push an element onto temporary stack 1, but currently it is not. The push function shown in the right hand side, you can see this is the push function, takes the global pointer top, which is the pointer to the topmost element of the original stack. You can see this over here, that this push function will always receive this global pointer top and will never receive top 1 and top 2 because it is designed like this, right? It takes the global pointer top, which is the pointer to the topmost element of the original stack. Therefore, push function is capable to add a new element in the original stack only. This function is capable enough to add an element onto the original stack and not onto the temporary stack 1 or temporary stack 2. What is the solution to this problem? How to rectify this problem? Instead of declaring the pointers globally, we can pass them locally to the functions. We know that our functions will always receive the top pointer, but we want our functions to receive all the other pointers as well. And one way to get rid of this problem is to simply pass all the pointers locally to the functions. This is one way out, right? Here, we will first delete all these pointers and we will declare them inside the main function. Then after this, we must redefine our push function. This is the first step, of course. We will redefine our pop function also, but first we will redefine our push function. This time, push function will receive the pointers locally. Here, this is how our push function looks like. You can see this push function will not only receive the data, but will also receive the top pointer. Please note that this top pointer is local to this function. And this is not same as this top pointer, okay? Although I have color coded them same, but they are not same. This top pointer is declared in the main function and is local to this main function, but this top pointer is a general pointer. You can think of this that this top pointer in future will receive top 1 or top 2 or top. Okay? So it is not the case that this top pointer is same as this top pointer. Now I think the idea is clear. We have declared this top pointer in this push function, and now we will pass top, that is this top, to this push function. This is the first requirement, right? First we will test this push function by pushing an element onto the original stack, and then we will work out with the other stacks as well. So here we are interested in pushing this element onto the original stack. Currently the stack is empty. You can see top is null. Therefore, we will call the push function for pushing this element onto stack. And finally, we will call the print function for the purpose of printing all the elements on the screen. That is, we want all the elements of the original stack must be printed on the screen after pushing them onto the stack. This is how our original print function looks like. And here you can see in this print function, top pointer is used. In the past, this print function was using this global top pointer, but now this print function must receive the top pointer locally, right? In the print function, we are using the top pointer. Therefore, we have to pass the top pointer to this function. So here, to this print function, we will pass the top in order to print the first element of the stack, right? And here, we will write struct node start top. This is the updated print function. Okay. Also, we are calling isEmpty function inside this print function. You can see this, that we are calling isEmpty function. And in this isEmpty function, you can see the top pointer is used. This top pointer is not local to this function. In the past, this function was using this top pointer, which is the global top pointer. Now we don't have any global top pointer. We must pass the top pointer locally to this function. So here we will write struct node start top, and in the print function we must put top over here. Fine. Now I think the idea is clear to you. Let's execute the complete code in code blocks. You can see the complete code over here. We have struct node, we have isEmpty function. You can see the parameter of this isEmpty function, struct node start top. Then we have this push function, and then we have this print function. And in this main function, 3 pointers are declared. And first we are calling the push function, and we want that one must be passed to the original stack, right? This means one must be pushed inside the original stack. After this, we will call the print function for the purpose of printing this element onto the screen, right? We are actually executing this program for the purpose of testing it. Now let's just test our code whether this is working fine or not. Oh, this is a problem. We got this message stack underflow, but we are expecting this value 1. Instead of getting this value, we got this message stack underflow. And you can see the process returned 1 as well. This means that this is an abnormal termination. There is something wrong in our code, right? We have passed the top pointer correctly. You can see that top pointer is null. We have passed null to this top pointer. Everything is fine, but we are getting stack underflow message. And you can see this, that process returned 1, not 0, which means this is an abnormal termination. Why stack underflow? We'll find out the reason in the next lecture. Okay.